In this video, we'll find the equation of a line that is tangent to a circle at a given point. We have, in this example, a circle is defined by the equation x squared plus y squared equals 100. Find the equation of the line that is tangent to the circle at the point -8, 6. So a little background real quickly. We have x squared plus y squared equals 100. That defines a circle centered at 0, 0, and having a radius of the square root of 100, or a radius of 10. So I've got just a real rough sketch here. It doesn't have to be perfect, just to get an idea of what we're looking at. The point, -8, 6, that's -8, +6. It's about here. Again, it doesn't have to be perfect. It's just, we're just getting an idea of what's happening. The tangent line will look like this. It just touches the circle right there. So again, it doesn't matter if it's just a rough sketch. That's what it looks like. I'm going to circle this -8, 6. That's our point right there. And then in red, I'll come through and draw this radius from the center of the circle out to that point. Okay. Now what we need in order to find the equation of this line is we need a slope and a point. We have a point. Nice. I'll check that off in green to show that we're messing with the green line. Now we need to find a slope. The slope of the tangent is going to be perpendicular to the slope of the line that the radius lies on. So the slope of this radius is just going to be the rise over the run going from the left to the right. That's how we always look at lines. And this line goes on forever. The rise over the run, or change in y over change in x, going from left to right. So the change in y is -6. Remember, we went up 6 to get there. So that's -6. And then the change in x is +8. So the slope, I'll call this the radius slope. The radius slope equals -6 over 8. Or, of course, we should simplify that to -3 over 4. Okay, let's look at the tangent line. The tangent line will be perpendicular to the radius, so the tangent slope will have a slope that is the opposite reciprocal of the radius slope. So instead of -3/4, the tangent slope is the opposite sign, so positive, and flip it over. So the opposite reciprocal, or negative reciprocal. Okay, we have a tangent slope, and the negative of a negative is a positive. So the opposite reciprocal. Now we have a slope, we have a point. Let's get to work. Let's use the point slope form. The point slope form is y minus y sub 1 equals the slope times x minus x sub 1, where x sub 1 and y sub 1 are the x and y coordinates of the point in question. So let's plug that in. We have y minus our y coordinate of 6. And we also have then the slope of 4/3, the tangent slope, multiplied by x minus our x coordinate of -8. So x minus a -8. Let's go through and multiply everything by 3 to clear out this fraction. So that gives us 3y minus 18 equals 4 times x, I'll say plus 8 because it's minus a -8. So what I did was I said y times 3 is 3y, -6 times 3 is -18, 4/3 times 3 is just 4, and this is multiplied already by this, so we don't multiply it again by the x plus 8. Now let's distribute that 4. So we get 3y minus 18 equals 4x plus 32. Now let's put this in standard form. And in standard form, we put the x and y on one side and all the constant terms on the other side. So I'll subtract 4x from each side and say negative 4x plus 3y. Let's at the same y at the same time add 18 to each side. So equals, that'll cancel that out, and 18 plus 32 will be 50. Almost there. One little technicality. In general, the standard form is written with the coefficient on x being positive. So let's just multiply everything through by -1. So that makes it 4x minus 3y equals -50. And that's the equation of the tangent line, tangent to the circle, at the point -8, 6. I hope that helps.